9-5 extension. This is called cross sections of three-dimensional figures, or sometimes the worksheet will refer to it as intersection of a plane and a solid. What we're looking at today as a definition is just a cross section. It's a two-dimensional shape. Notice it's two-dimensional shape that is the intersection of a plane and a solid. So we have some sort of a 3D shape here that we are just going to slice or cut, if you will. Well, you'll see kind of like in a picture here in the next slide that it looks like a piece of paper has been put there, or you can even just imagine that you're cutting it with a knife, or like you'll see on our worksheet, usually there is like cheese that gets sliced or something that is getting cut, and we have that cross section. When we talk about a plane, that's this guy right here. That's this like piece of paper, if you will, which is going to be slid through or cut this solid, or this, in this case, this rectangular prism. And then our intersection, our cross section, is just this shape right here. And in color, it's nice because we can see it. Jumps out a lot nice for us. It's the purple, and whatever shape that is, we just say it. No formula, no work, we just say it. So in class, I would have some of these shapes maybe in front of us and be pretending to like slice them. But here, we're just looking at the first one in the upper left where we talk about the intersection or this cross section here. When you look at that purple, the purple color, what shape do you see? A triangle. That's all you write down. That's it, because we're talking about the intersection or the cross section. Over here on the right, we can see again, we've got this plane here, this piece of paper thing that we're going to slice or cut this pyramid with. And if I were able to pick this part up right here and face it towards you, what shape would you see? What is this purple thing here? And without having any information on the bottom, this is where usually I would say it's a squarish rectangle, meaning it's probably a square. Maybe it looks a little bit like a rectangle, but since they didn't give us any numbers, for the most part, usually I'm okay with either. This one, I would go a little bit more with a square. Down here in the bottom left, though, this one, again, the purple we see here, that one's definitely a rectangle, so we want to make sure we call that one a rectangle. And here, notice in class, I'd say, what kind of shape is this? And I said, I would pretend if I was cutting it over here with a pretend plane or something like that. But what that shape is a cylinder. What's the base or the main shape through a cylinder? A circle. Well, when you take a horizontal cross section, you're going to get that as well. So something quick here for you to write on in with this video here. I want you to put down the word horizontal. I'm going to kind of put it here in the middle because notice how the first, the second one, and the last one all were horizontal cross section, or the plane was going horizontally. Again, remember, horizontally is like the horizon going left and right. And when you have those, that cross section is going to be the shape of the base, or in this case, the bottom. Notice again, the main shape in the triangular prism was that triangle. The bottom, so a horizontal will be a bottom. The bottom will be a triangle. In a square pyramid, the base is a square, so a horizontal plane is a square. And the main shape, the base on that cylinder, since it's a horizontal, it's going to be a circle. Over here, this one on the bottom right, this one's a vertical. That one is a vertical intersection or a vertical cross section, so that one's going to be whatever the front view looks like. So notice how from the front we have this rectangle, so a vertical cross section is going to be just that. On to the next one, scribe and describe the intersection of a horizontal. Notice that one's important right there since it says horizontal. We would, if we wanted to draw a piece of paper in here, cutting it, we could. Or again, in class, I'd hold this square pyramid up and say, what would happen if I were to cut it horizontally? Hi-ya! And show you, just like if I were to take this and just cut it right whoosh, like that. And if I could lift this part up here up, what shape would you see on the bottom? Well, again, from our last slide, since it's talking about a horizontal cut over here, that means it's going to be the view of the base or the bottom. So since our bottom is a square pyramid down here, There's our horizontal view, not quite drawn to scale, but that would be a square pyramid. Notice that's describing it. So now it says to sketch it. So then let's just sketch that quick. What does it mean? Well, just like our intro to this, just draw the square or the shape as you would see it, the rectangle, whether it's going up and down vertically or side to side horizontally. And that's cross sections. I can describe the intersection of planes and solids. So there's a video that you can watch about the Slice Master 3000. It's not a video I made, but you can watch that once, twice, three times, as much as your heart desires. And then there's an assignment.
Tired of all that chopping and slicing.
Ah, this cube just won't cut.
Such hard work, and it takes forever. My geometry fruit salad's all lumpy. Now there's a better way to transform those 3D shapes into perfect 2D shapes. The Slice Master 2000. It lets you slice, 3D figures into perfectly flat 2D shapes. Great for squared potatoes, oh right.
Delicious.
With just one flick of the easy slice handle and an entire sphere is sliced into circles. In seconds! No odors, no tears. With Slice Master 2000, transform any 3D shape into a 2D figure with just a flick of the wrist. By 182 1/4. Now! It's like so easy. Pyramids can become squares. Rectangular prisms can become rectangles. Cuboids can become rhomboids. That's a thing? It totally is. Oh, that is so totally cool. Wait, no, not you. No, keep mine. At the heart of the Slice Master 2000 is the patented Plane Creator. Three-dimensional objects have 3 dimensions: length, width, and height. But when our Plane Creator intersects a 3D shape, the height gets chopped off. All that's left is a 2-dimensional slice, length and width. It's goodbye height, hello 2D slice. Cutting 3D shapes the old way can be dangerous. But with Slice Master, your hands never touch the plane. Turning spheres into circles has never been so easy, especially if you're blindfolded.
Can I take this off now?
No, but wait, that's not all. Use the angled Jinsu cut adapter, included to create a bouquet of slices from a single 3D object. Drive the Jinsu adapter through the apex of a pyramid, you get a triangle. But cut it horizontally, you can get a square. Cut it vertically, not through the apex, get a trapezoid, all from a single object. Add the deluxe linearizer, and the Slice Master 2000 removes both the height and width, creating mouth-watering one-dimensional segments, 2 points connected by a line, in seconds.
Great for stir fry.
The best part of the Slice Master 2000 is the price. It's totally free, because it already exists in your mind. Have a homework problem where you need to take a 2D slice from a 3D object? Place that 3D shape into your Slice Master and slice it with your mind. Perfect 2D slices every time. Slice Master 2000, the 2D slice that's great for life. Best thing is your hands won't even touch the plate.
Scene 13, take 1, product shot.
Are you saying that right?
No.
Oh,
Start with your line.
Slice Master 2D1000. Oh, why am I 2D1000?
Sorry, my bad. I thought it was bad because I said it to you. My bad. Whoa, okay.
Here,
Oh, this one gets stuck.
It lets you slice those 3D shapes into perfect 2D proportions. Not the right line. Oh, I can talk fast. Okay. But I'm still not done. Call right now and we'll throw in our patented mechanical bonding system, which enables you to transform your 2D shapes back into their original 3D form just in case you totally messed up. For free! Math Club approved.
So I didn't make that video. You're welcome to watch it again and again if you'd like to. Otherwise, quickly, here comes our extension review and also our volume review. Notice again, you use the clues If they give them to you, find the volume of the prism. What a wonderful thing right there. It tells you they're prisms. So our formula for prisms is V equals big BH. Remember, it's a prism if it has the same shape all the way through. Number 2 is not a pyramid. It does not come to a singular point. What is the main shape pushed all the way through? You may highlight, you may outline or not. Doesn't matter. But now we're going to focus in on this guy. No, you just can't write the formula once. You got to write it here as well. V equals big BH. Remember, big B stands for area. Everybody say area. Did you say area? Again, big B is the area. Since it's about this base, this shape, it's all about that base. No trouble. We're not going to use the rectangle formula because we've got a triangle here. So make sure you remember, since you've outlined or focusing on a triangle, you're going to use little b, base of the triangle, height of the triangle. The right angle is your friend. So you're going to take that 6 times 15 divided by 2. Grab that calculator, type it on in, or mental math. Again, if you're using mental math or calculator, be very careful you're typing it in there the right way. And then, like we talked about previously, what is the height of this prism? What is the distance from this triangle in the front to the triangle in the back? Sometimes our life hack works of what's the only other number we haven't used yet. So that gets you the answer, 360 feet cubed. We're talking about the amount of space inside a three-dimensional object. You can see down here, this worksheet is set up that if you wanted to say the area of the base was 45, you could. But normally I say you don't have to do that. As well, if you wanted to take and put your answer for volume down here in the blank, you can. But you see I've got all my work up here. My formulas, 2 works, answer, and a label. That's what we need on every one of the problems. Again, those are prisms. When you turn to the back, again, it says find the volume of the solid. So it didn't quite help us out on that one. That's okay. Is this one a pyramid? Does everything come up to a singular point? It does. So on number 6 then, think back to the rice or the illustration I showed about how many times did it take to pour the pyramid back into the prism. Since it took 3 times, that's where this 3 is coming in. A pyramid is 1/3 of the prism. So here we are again. Big B stands for area of the base. In the pyramid, it's the bottom shape. Oh no, another triangle. Little b, little h, divided by 2. If you need to cover up stuff on the top with your fingers, please do so. So you can focus in down here on the bottom on this guy. We're going to take 5 times 2 and divide it by 2. Calculator or mental math is great. Plug that in for the area of the base. Again, if you wanted to write that down below, you could. Otherwise, here's the height from the tippy top down to the bottom of that is 3. So take 5 times 3. Don't say that answer. It equals, then divide by 3. So that way you can continue all the way through. And because we're talking about space inside a three-dimensional object, that's why your label is meters cubed. So you got some volume of prisms, you got some of pyramids, and then you also have some more of these intersections, or what will be called cross sections. So again, it's not in color this time, but it's this purple spot here in the middle. What shape do you see? Call it that way. Over here on number 5, notice again, this one's a little off, but you take this cheese and slice it. You got what shape here? Triangle, so you just write that on in. No formula, no work. We're just naming the shape seen from the cut on both sides. So don't forget there is a back. And looking at those again, and if you need some shapes, always come on in so you can see them in front of you in class.